Hey guys, Dr. Brown here with Kubo Math coming to you from Tarlac City, Philippines. And tonight we have Algebra 2 multiplying radicals. You recall in the last video we were adding radicals. So tonight we're going to be multiplying those. And you know me, I'm a rules guy. And I think we've talked about this before, but when you look at the square root of a times b, we can break that out into the square root of a times square root of b. Okay, so we can break that apart, or if it's apart, we can put it together. Now, you'll know if you have the square root of, let's say I have a raised to the power of m times a to the n. We've said before, well, that's a to the m plus n. You also know that when you have, let's say, the square root of a times the square root of a, it just equals a. The radical sign drops off. Well, why is that? Actually, with the square root of a number, if it doesn't have anything over here, like these have the fourth to the third, you know, this would be the third root of 8. This is the fourth root of this. Well, this one is really the second root, the square root, okay? Well, really that is, let's say, if I have the square root of a to the second root, that's really a to the 1/2. Which is what this is. So here I have a to the 1/2 times a to the 1/2. And what did we say? A to the m times a to the n is really, I'm adding those two exponents together. So that is a to the 1/2 plus 1/2, and it is a to the first. So it's just a. That's why that radical sign disappears. Now, we can expand this rule, since we have other roots here, we can expand it to the nth root. So if I have the nth root, and let me clean that up. I'm sure you can't see that. Here, let's just clean up here, get us a better spot. And a better eraser. All right, if I have, I'll make that bigger. I have the nth root of a times b. Well, that equals the nth root of a times the nth root of b. Then the nth root, let's say I have 8, and it's the cube root of 8. Now really that's 8 to the 1/3 power. To the 1/3, that's what that really means. But it also, you could interpret that would be, what number can I multiply by it times itself 3 times, n times, in this case 3, that would be 2 times 2 times 2, that equals 8. So what number can I multiply times itself 3 times to give me 8? 2 times 2 times 2 equals 8. So the cube root of 8 equals 2. All right, so that said, let's dive into some of the problems we have here. All right, so we have, in this case, the square root of 4 times the square root of 25. Well, square root of 4 is 2. What number times itself 2 times, because that's, remember, the nth root, the square root sign is really, there's a 2 up there, we just don't write it. Okay, the square root of 4 is 2, square root of 25 is 5, 2 times 5 is 10. Now I could have put those back together. I could have said, well, 4 times 25 is 100, so the square root of 100, well, okay, that's 10 also. What number times itself 2 times gives me 100? 10 times 10 equals 100. Uh-oh, did I just, hopefully we still have sound. Okay. All right, what about this guy here? Square root of 8 times the square root of 2. Well, Square root of 8's not so obvious, is it? But we can break that apart. I could say, well, that's the square root of 4 times the square root of 2. Okay, square root of 4 times square root of 2 is the square root of 8. Okay, that's times the square root of 2 I already had. Hey, this is cool. Square root of 4 is 2. Now the square root of 2 times the square root of 2 is 2. 2 times 2 equals 4. Well, I could have said square root of 8 times square root of 2 is the square root of 16. Square root of 16 is 4. Okay, what number times itself 2 times gives me 16? 4. Okay, following along those same lines, so let's look at this one here. Let me get it over here where it's a little easier to see. Square root of 5 times square root of 10. Well, let's factor the square root of 10. So we have this square root of 5 times square root of 5 times square root of 2. So this would equal square root of 10 if I multiply those two together. But now I have the square root of 5 times the square root of 5. And that gives me 5 times square root of 2. So the square root of 5 times square root of 10, the results would be 5 square root 2. Okay. Let me clean up a little bit here. All right. What about this crazy looking one here? 6a cubed times, the square root of 6a cubed times the square root of 18a. Yeah, hey, let's put these together. All right, let's just say we've got a big square root sign here. Okay, 6 could be 2 times 3. A cubed, I'm going to multiply it times a, which would give me a to the 4th. We'll move it kind of to the end. And I'm going to break 18 into 2 times 9. So now I have 2 times 2 is 4. So I have the square, all this is under square root sign now. I have 4 times 3, well, let's break it out. We have square root of 4 times square root of 3. So that was these numbers here. Times square root of 9. I'm just going to go ahead and say that is 3. And then the square root of a to the 4th, which is a squared. So I have 2 times 3 times a squared times the square root of 3. So 6a squared square root 3. That's what that square root equals. So you've all been through factoring. Just break it apart. But you're trying to, in many cases, end up with perfect squares. Like 2 times 2 is 4. So I know the square root of 4 is 2. Now I could have said, well, this is square root of 2. That's that one. Times square root of 2. That's that one. Times square root of 9. That's that one. Times square root of a to the 4th. That's that one. Times the square root of 3. So remember the radical sign times the radical. So square root times the square root. Those drop. So that's 2. Square root of 9 is 3. Square root of a to the 4th is a square, and then square root of 3 is still square root of 3 because I don't know what that is. Actually, it's 1.73, but that's okay. All right, 2 times 3 is 6. A squared square root 3. So there's different ways to go about this. Okay. All right. What about this one up top here? We have the cube root of 8 times the cube root of 27. Well, what number times itself 3 times would give me 8? 2 times 2 times 2. So the cube root of 8 is 2. What's the cube root of 27? What number times itself gives me 27? Well, that's 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So the cube root of 27 is 3. So if I multiply the cube root of 8 times the cube root of 27, the answer is 6. You know, some of these are not so obvious. Take this one, for example. Speaking about not obvious. Okay, this one, I think I'm going to put these together. If I bring them back together and multiply some things, this x squared times that x squared becomes x to the fourth. So I have a perfect square. Okay, well, I'm going to take the fourth root of it. So actually that works out well that it's going to be to the fourth power. Then I'll have 48 over 3. So let's do that. Let's put these all together. So it's 48 x squared, I should put that to the fourth root, times x squared over 3. So it's the fourth root of that. Well, you know, now I've got this 48 over 3. So 48 divided by 3 is 16. That's still to the fourth root. X to the fourth. What number times itself, and keep in mind I could break this back apart and now say that I've got the fourth root of 16 times the fourth root of x to the fourth. What number times itself 4 times gives me 16? 2 times 2 is 4, times 2 is 8, times 2 is 16. So the fourth root of 16 is 2. The fourth root of x to the fourth, what number times itself 4 times can give me x to the fourth? X. X times x times x times x gives me x to the fourth. So all of this equals 2x. See, that's not so obvious that that's where you're going to end up. Okay, I've got a few more over there. So let's clean us out a spot to work, see what we can do. All right, we've got the square root of 3 times a parentheses of 2 plus square root 3. Now we're going to distribute that square root of 3 to the inside just like you would any number. So now 2 square root 3, and the preferred convention is to write the number first and the radical numbers next. Okay, you'll notice I put that radical here. I even had the variable in front of it, so it ended up sort of last. So we'll do that here. Plus square root 3 times square root 3. All right, so let's simplify that. We have 2 square root 3, and then the square root of 3 times the square root of 3. The radical sign drops and I have 3. So that would be the simplest form of that. 2 square root of 3 plus 3. Okay. What about this next one? 3, let's see, 2 plus square root 5 and 1 plus square root 5. Now you've learned the FOIL method by now. So we'll do first times first. So 2 times 1 is 2. Outer times outer. So I have plus 2 square root 5. Inner times inner plus 1 square root 5. I'll leave the 1 off, but it's assumed here. And then the square root of 5 times the square root of 5 is 5. Radical sign drop. So now I have 2 plus 5 is 7, plus 2 square root 5 plus 1 square root 5 gives me 3 square root 5. So I have 7 plus 3 square root 5. Okay. Along those same lines, we have one that is 3 minus square root 2 and 3 plus square root 2. We'll do the FOIL method again. First times first, 3 times 3 is 9. Outer times outer plus 3 times square root 2. And then inner minus 3 square root 2 minus square root 2 times square root 2, which is 2. So you notice that minus, so it was minus square root 2 times square root 2. So negative times a positive still gave me a negative. And then the radical sign dropped away. All right, so 9 minus 2 is 7. So positive 3 square root 2 minus 3 square root of 2, those cancel. And I end up just with 7. 9 minus 2. Because we learned before about adding and subtracting radicals, it's a lot like the denominator in a fraction. You can only do that if the radicals, what's under the radical is the same. If this had been a square root of 5, I could not have simplified that anymore. Okay, this next one. What if you just had something simple like, what's the square root of 12 squared? Well, that's square root of 12 times itself, right? 2 times. Well, now that just equals 12 because the radical sign drops. So don't let them throw you off by adding a little bit of a different look to it. Just have to back up and ask yourself, what is that? What is it really saying? For example, this one, x cubed times 4x, square root of 4x. We can combine these and end up with a perfect square on the x term. So if we put them all under the same radical sign, that's 4 times x cubed times x, which is 4x to the 4th. So that's the square root of 4 times square root of x to the 4th. So that's 2 times x squared. So 2x squared. So the square root of 4 is 2. Square root of x to the 4th. What number times itself 2 times gives me x to the 4th. That's x to the square, x to the square. Remember, a to the m times a to the n is x to the m plus n. So that's x to the 2 plus 2, x to the 4th. All right, I think that's all the problems I had. So this was just an example of multiplying radicals. And hopefully you've enjoyed it. Hey, and why are we doing this? Because together we're trying to build a better tomorrow and do that through math. Practice, 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 okay? All right, that's all for now, and we'll talk to you next time. Thanks.